So what they say is that there is a projectile that has been shot at some angle theta with respect to the horizontal at some speed u. So there is a horizontal ground and it has been shot. So there is a projectile that has been shot at some initial speed u at some angle theta with the horizontal. And then they ask you what happens or how far away is it from that starting point after it has bounced over for n number of times. So the thing is, it'll go and hit the ground again somewhere, and at that place they say that the coefficient of restitution is e. So that means it's going to bounce off. So once it bounces off, it's going to go and hit the horizontal surface somewhere else. Then at that place also the coefficient of restitution is e, and then it's going to bounce off again, and then it's going to fall off somewhere else. So in that process, how far away from that initial point will it be after n bounces? That's the kind of thing that they ask. Let us say, we have to solve this particular problem. So by now I think you would have got an idea that the first motion will be like a projectile. So it'll hit the ground somewhere, and after hitting, once it rebounds, the next motion is also going to be like a projectile but at some other angle, and the third motion is also going to be like a projectile but at some other angle, and like that. So this is how the ball is going to go and keep on bouncing again and again after hitting the ground. And the first range is R1 probably, the second range is R2 probably, and the third one is R3 probably. So basically they are asking us, so here is the first collision, here is the second collision. So after the first collision, it's R1 away. After the second collision, it's R1 plus R2 away. After the third collision, it's R1 plus R2 plus R3 away, and so on. So what they're essentially asking you is the sum of all the ranges. So R1 plus R2 plus R3 plus R4 plus up to Rn. So if I show you these distances as R1, R2, R3 and so on, then after the nth collision it will be, so therefore the required distance is R1 plus R2 plus R3 plus so on up to Rn. And how do we find range? Now for range there is a wonderful formula, that's u square sine 2 theta by g, but then we can also write that formula in terms of ux and uy, and we can say that range is, now since range is u square sine 2 theta by g, we can also write it as 2ux uy divided by g, and in this case I think it will be easier to use this formula ux uy by g. The first time when this ball is thrown, its ux is u cos theta and uy is u sin theta, and then it goes and hits the floor somewhere, it hits the ground, and then it rebounds. When it rebounds, the x component does not undergo a change, assuming that the ground is frictionless. So let's say that there is no friction between the ball and the ground. There is no friction between the ball and the ground. So these are the assumptions that we are working with. So once it rebounds, only the uy changes, the ux does not even change here. Then it goes and hits the ground somewhere else. So again the ui changes, but the ux does not even change. And what will uy become? Now for initial case here, we had u sin theta, and we had u cos theta horizontally, u cos theta. So after the first collision, we will have vertically eu sin theta and horizontally u cos theta. And then after the second collision here, we will have e squared into u sine theta, because again here the speed at which the ball would be approaching the ground will be eu sine theta, and the speed at which it is going to separate should be such that e is equal to that speed of separation divided by eu sine theta. So you will have e square into u sine theta. This is going to be e squared u sine theta, and you will have u cos theta horizontally again, and so on. So the series will go on, and then you see that it's easy to find out what is that sum that we are after. So therefore I can say, therefore required distance is equal to 2 ux uy by g plus 2 ux e times uy divided by g plus 2 ux e square times uy divided by g plus so on. And you see that for R1 I don't have e, for R2 I have got e power 1, for R3 I have got e power 2, so for Rn I am going to get e power n minus 1, 2 times ux e power n minus 1 times uy divided by g. And then, as all of you would have guessed, it's only the sum of a GP. So you've got 2 ux uy divided by g into 1 plus e square plus so on plus e power n minus 1. So you know that this is the sum of a GP, and you know the equation for that also, so you can express this entire thing in terms of the first term multiplied by, I believe, 1 minus r power n by 1 minus r. I think that's the expression for the sum of a GP in mathematical notations. But then a very interesting case is when I'm asking you what happens after infinite bounces. So if the number of bounces are infinite, then after infinite bounces, what I'm going to get is distance d is equal to 2 ux uy divided by g times a over 1 minus r. So a is 1 here, that's the first term, and 1 minus r, which is in fact the common ratio, is going to be e. So this is the answer. Then and then of course you can substitute for whatever ux is and whatever uy is. So this is how far away the ball will be, and then you can easily guess what happens for a perfectly elastic collision. If there is a perfectly elastic collision, then e is 1, then here the denominator becomes 0, and if the denominator is 0, then we have got d as infinity, which is in fact true, because then the ball will keep bouncing on. So it will never ever stop, it will keep on bouncing, and then it will be infinitely far away from this initial starting point after infinite launches. What happens if e is 0? If e is 0, that means it never bounces again. So what happens is it goes, hits the floor or hits the ground here, and then it goes on sliding. So because they were asking you after n bounces, there is only once that it is going to hit the floor, and it's not going to rebound ever again. So you can probably think of the distance as 2 ux uy by g. So after it hits the floor for the nth time, which is in fact only once, if e is 0, it will be 2 ux uy by g.